So let's talk about few more things. Heat and internal energy. These are some basic thermodynamical ideas or concepts. What is internal energy? So we know that everything is made up of atoms, um, whatever we know about. And these atoms actually have their motion of their own, the motion of their own. So if you have, let's say, some metal thing or anything actually, this guy will be is made up of different atoms, and each atom will have its own motion. There'll be these various atoms will be actually vibrating on their places. So let's say this atom here is gonna vibrate, I don't know, in many different ways. So there's some vibration energy in this case, and let's not talk about what kind of energy they carry, but they will have some energy. And this energy, this whole sum of all energy carried by all these atoms, we know that energy can be added, it's a scalar, is called the internal energy of the system. Now you can have a case when you have, let's say, a gas enclosed in a volume V. Now in this case the gas molecules will be moving, and if there are two molecules which are bind with each other, they will be vibrating. So there will be vibrational energy, translational energy, and this again will be nothing but the internal energy of the system. So in this case we'll have translational, which means energy because of the motion, linear motion, and vibrational, which means because sitting at one place but is vibrating left and right, energy. Now this internal energy can be increased or decreased. Let's say if you have this metal bar which is at room temperature, and if you keep it in space, take it in the space, this guy is floating, we know that these molecules are going to emit radiation, and in the process will lose their internal energy. As a matter of fact, they will keep losing their internal energy, or this radiation, and the internal energy will keep reducing until the temperature of the metal bar matches with the temperature outside. It's said that for space, I think the temperature outside is 3 Kelvin, which is very low temperature. So you see that the internal energy decreases here, but on vice versa, you can actually take this metal bar and put it on top of a furnace. We know it will become red hot, and the internal energy of the system will increase. So what is that thing that is increasing the internal energy of the system? And this is nothing but the heat. It is the heat that increases the internal energy of the system. In this case, the guy lost heat, and there was a decrease in the internal energy of the system. In this case, the guy gained heat from the furnace. There was an increase in the internal energy of the system. Now there's another thing that is used in conjunction with heat, is called work. Let's just write what is heat. Heat is something that increases internal energy. Okay, what is work? Now work is same as heat, but work can move things, which means it can, as simple as that, we say we can do work. For example, let's say you have a fan. Simple ceiling fan. It's moving. So this guy is doing work. And we know in mechanics that work is defined as force applied times distance moved times the angle between the force and the distance. This is work. This is force vector, this is distance vector, the angle is theta, we know this is work. Now what is different between heat and work? We know that we can use heat to do work. For example, steam engine. There's coal, the coal burns, it produces steam, the steam pushes the piston and the engine moves. Moreover, we also know that work can heat things. For example, if you have a metal thing or anything actually, and you have a surface, you move it up and down and rub it on the surface, we know that we are doing work, and what will happen? The surface will heat up. So these are actually the same thing. They are like they have the same. They can be categorized in the same way. Heat can be changed to work, and work can be changed to heat. The only thing is that all the work can be changed to heat. So if you do some work, all of it can be changed to heat, but not all the heat can be changed to work. So work to heat 100% can be changed, all of it, but heat to work can only be changed less than 100%. Okay, something less than 100%. And this is because of the second law of thermodynamics. You don't have to worry about that. And so these are the few basic concepts which I thought I'll introduce. One more thing, the unit of heat. The unit of heat is defined as 1 calorie because it's heat. This is defined as heat required to increase temperature of 1 gram of water. Sorry for my bad handwriting. By 1 degree centigrade. This is how heat is defined. As we saw that heat actually increases temperature. So this is how heat is defined. Work is measured in joule, and 1 calorie equals, I think it's 4.186 joules. We know that joules is the unit for work, and you can know that joule is nothing but Newton meter. So you see, force comes, Newton comes from force, meter comes from d, distance. But the difference, we already know that not all the calorie can be converted to joules, but all the joules can be converted